Alright, so in this example video, we have a box of books of mass 10 kilograms that's given an initial velocity 5 meters per second up an incline of 5 degrees. So I've drawn my incline and we're going to start down here. So our V initial is going to be right here, so V initial is 5 meters per second. And we want to know how far up the incline does the box of books go before coming to a stop. So at y final, our velocity is going to be 0. So velocity final is equal to 0 meters per second. And since we're starting at the bottom of the incline, y initial is also equal to 0. Alright, and we're also told that the frictional force between the box and the incline is 20 newtons. Alright, so we're going to apply conservation of energy in order to solve this. So let me write out our conservation of energy formula. So we have 1/2 mass velocity initial squared plus mgy initial plus work non-conservative is going to equal 1/2 mass velocity final squared plus mgy final. Alright, so we've already established that V final is 0, so that means we don't have to worry about final kinetic energy. And we've already established that Y initial is 0, so we don't have to worry about our initial potential energy. And we have to remember here that work non-conservative is going to be the force non-conservative times the displacement of the object. In our case here, that's going to be the negative force of friction times the displacement. Now, as we go through our checklist of information we have the mass, we have the initial velocity, so I've written them down here as provided in the problem. We know what the frictional force is. The displacement is our unknown because we want to know how far up the ramp the object goes. We have mass, we know what the gravitational field strength is, but we don't know what y final is. So that's why I've drawn this triangle here, because I'm going to write y final in terms of the displacement, because we're assuming our incline here is a right triangle. So the displacement would be the hypotenuse of the triangle, and delta y would be the side of the incline opposite to the angle provided, so the angle of inclination. Because delta y is opposite to the angle of inclination, and I am looking for the hypotenuse, I'm going to say that the sine of theta is equal to, I just put y final because we've established that y initial is 0, and divided by the hypotenuse, which is our displacement. So I can rearrange that and say that y final is equal to the displacement times the sine of theta. So I'm plugging this relationship in for y final. And this is where we start up here. So I have my initial kinetic energy minus my work non-conservative equals my final potential energy. So I'm going to plug in 1/2 times 10 kilograms times 5 meters per second squared minus 20 times our unknown displacement is going to equal 10 kilograms times our gravitational field strength times our unknown displacement times the sine of 5 degrees. And going through the algebra, that gives me a displacement of 4.38 meters. So the box of book travels up the incline a total of 4.38 meters per coming to a stop.